Okay, sorry that this is kind of late, but here's 9.5, functions and their inverses. We want to determine whether the inverse of a function is a function, and write rules for the inverses of functions. Okay, so we're going to start off with the determining whether an inverse of a function is a function. And you have to recall, like from a graph, we had something called a vertical line test. When we did the vertical line test, that allows us to look at a function and decide if look at a relation and decide if that function was whether that relation was a function. And you can see here, like this little blue line that I've drawn, that's vertical with this diagonal line. If I were to drag that all the way across and make multiples of that, or drag it across, there would never be a time where the graph touches the blue line twice at the same time. So that would pass a vertical line test and thus would be a function. Now there's also another test without having to find the inverse, just by looking at the graph and without having to just kind of going from there. You can do something called the horizontal line test. The horizontal line test will help you determine if it's an inverse. And you can see by this red line that I've drawn that if I were to move that one up and down, that the current graph would never touch that line twice. So then I would know that the inverse would be a function. So let's look at some more examples. So we're going to determine if these are, say, horizontal, if the inverses of the relations would be functions. Okay, I'm not worrying about if the graph itself is a function. I'm worrying about if it's inverse. So you can see here, like if you look at this graph, and you were to go based off of the vertical line test, it's not a function, but I'm not worried about that. I'm looking at horizontally only. Okay, and if I were to go up and down there horizontally, there's never a time where the graph touches the horizontal line twice at the same time. So yes, the inverse here would be a function. Whereas if I look at the next one, you can see here with a horizontal line, it's touching it at 3 different spots at the same time. 1, 2, 3. So this one, even though the graph itself is a function, its inverse is not a function. And that's what we're trying to hear. Determine if the inverse is not so much as a relation as it is a function, because they're always all relations. Okay? So there you go with that. That's pretty easy. You just look at the graph and kind of go from there. Okay, I want to go over a special type of function in the relationships. If both the relation and its inverse are a function or functions, the relation is known as a one-to-one function, which means there's only one y to each and every x. This type of function would pass both the vertical and horizontal line test, so that's something to keep in mind. So I might ask that on the quiz. I don't have an example of that really right now, except for maybe the very first example, which was a linear function. But kind of keep that in mind. If it would pass both, then it would be known as a one-to-one function. So I may ask that on a test, like is the inverse a function? And then I might ask, is the function or is the relation a one-to-one function? You know, yes or no type of thing, true or false. Okay. The next part is I want to see if I say two things are functions, f of x and g of x. If I know they're functions, I want to know if they are inverses. And the way we can know this is that if I plug one into the other both ways, like put g in place of the x of f of x and f in place of the g, or in place of the x for g of x, and if I combine that, composite that together and simplify it and it gets me down to an x for both of them, then they are inverses. For example, if f of x is equal to 1/4 x squared and g of x is equal to 2 times the square root of x. Okay, so first thing is I'm going to look at f g of x, which means I'm going to put 2 square root of x in place of the x in the 1/4 x squared. So I'm going to go 1/4, and instead of x, I'm going to put 2 square root of x, and then outside of that squared, because it was x squared. Well, if I square that, 2 squared is 4, and x squared of x and square would cancel each other out. So I'd be left with 1/4 times 4x. Well, the 1/4 and the 4 would cancel each other out, leaving me just x. Okay, now that worked, so now I need to check the g of f of x. So I'm going to put the 1/4 x squared now in place of the x under the square root. The square root of 1/4 is 1/2. The square root of x squared is x. So I'd be left with 1/2 x. 2 times 1/2 would cancel each other out, leaving me x. So since both of them give me just an answer of x, I'll say that f and g are inverses of each other. Let's look at the next one. F of x is equal to 2x plus 4, and g of x is equal to 1/2 x minus 4. Plug that in. I'm going to put 1/2 x minus 4 in place of the x. So I'm going to say 2 times 1/2 x minus 4 plus 4. 2 times 1/2 is x. 2 times 4 is 8. And then negative 8 plus 4 is negative 4. So since my answer does not equal x, I don't even need to check the other one. F and g are not inverses of each other. Okay, so last thing I want to do is write a rule for an inverse. Okay, so let's look at that. Okay, so we have here x cubed minus 2, and I'm going to switch the x and the y. Solve, add 2, so I have x plus 2 equals y cubed. How do I get rid of a cube? Cube root, so I'm going to do cube root. That would give me x plus 2 like that equals the inverse. Okay, that's as far as I'm going to go with that. There's a little bit more I could ask about that, like what's the domain and range, but I'm just going to ask you to find the inverse, which there that is. Okay, so now let's look at another example. Okay, here I have the square root, it's 1/2 x plus 2 squared for f of x. Now, switch the x and the y. Notice again, I'm just saying the f of x is y, so I'm just switching them. Okay, how do I get rid of a square? I need to take a square root. But you got to remember, when you take square roots in algebraically, you got to say plus and minus. Square root of x is equal to 1/2 y plus 2. Well, subtract 2, so I'll have plus and minus square root of x minus 2 is equal to 1/2 y. How do I get rid of 1/2? Multiply by 2. So now I'm left with 2 parentheses plus and minus square root of x minus 2. Close that parentheses is equal to the inverse. Now you could say, well, okay, I look at this and I look at the other one. This could be an inverse. I would have to, I guess, combine them to see if they are. Whereas this one, because of the plus and minus, you should be able to tell that that automatically is not an inverse. But again, I think I'm just going to worry, not a function. I'm saying inverse, but it should be not a function. But I'll probably leave it like this. Just find the inverse, and then we'll kind of go from there. Because we can do the finding if whether that inverse is a function from some of the other things that we're doing. That's it for 9.5. The next one should be 9.1. We'll see. But that's it for today. Thank you very much.